Hi, I'm going to go through the International A-Level Statistics S2 paper from January 2024. Question number 1. The manager of a supermarket is investigating the number of complaints per day received from customers. A random sample of 180 days is taken and the results are shown in the table below. Part A, calculate the mean and the variance of these data. So we know that the mean is calculated by sum of xf over sum of f, and the variance is calculated by sum of x squared f over sum of f minus mean squared. So we're going to calculate sum of xf and sum of x squared f, where x is our data, f is our frequency, so we calculate xf and x squared f. So for xf, we'll get 0 times 12, that's 0. 1 times 28 is 28. 2 times 37 is 74. 3 times 38 is 114. 4 times 29 is 116. 5 times 17 is 85. And 6 times 19 is 114. And finally, we have 0 here. So here, sum of xf is going to be 531, and to calculate mean we need to divide that by sum of f. So sum of f is, as the question says here, is 180. So mean is going to be equal to 531 over 180, and that gives us 2.95. For variance, we need sum of x squared f. So x squared f is going to be 0 squared times 12 is 0, 1 squared times 28 is 28, 2 squared times 37 is 148, 3 squared times 38 is going to be 342. 4 squared times 29 is 464. 5 squared times 17 is 425. And 6 squared times 19 is 684. And finally, we have 0 here. And then sum of x squared f is going to be 2091. And so variance is sum of x squared f, which is 2091, divided by sum of f, which is 180, minus mean squared, which is 2.95 squared. And that gives us 2.91. Part B. Explain why the results in Part A suggest that Poisson distribution may be a suitable model for the number of complaints per day. So we know that a Poisson distribution is appropriate when the mean and variance are approximately equal to each other. So we saw in Part A that mean was 2.95 and variance was 2.91. They're very close to each other. So we write in Part B, for the answer we write the mean is close to the variance. Part C. The manager uses a Poisson distribution with mean 3 to model the number of complaints per day. For a randomly selected day, find, using the manager's model, the probability that there are, part I, at least 3 complaints. So here we first define our random variable. So we say that let W be the number of complaints per day, and W is distributed with Poisson distribution with lambda 3. So we have to calculate probability of, as the question says, at least 3 complaints. So we want W to be bigger than or equal to 3. So that's equivalent to 1 minus probability of W less than or equal to 2. So we go to the Poisson cumulative distribution table. We go to lambda equal to 3, and we go to x equals 2. So that means that we get that probability of W being less than or equal to 2 is 0.4232. So in our calculation we have 1 minus 0.4232, and that gives us 0.577 to 3 significant figures. Part II, more than 4 complaints but less than 8 complaints. So we want probability of W to be bigger than 4 but less than 8. And since Poisson distribution is a discrete distribution, so that this is the same as probability of W less than or equal to 7 minus probability of W less than or equal to 4. So again we go to the table. Let's delete these ones. This time we have lambda equal to 3 again, but we're looking at probability of less than 7, which is 0.9881, and probability of less than or equal to 4, which is 0.8153, and we subtract them. So we have 0.9881 minus 0.8153, and that gives us 0.173 to 3 significant figures. Part D. A week consists of 7 consecutive days. Using the manager's model and a suitable approximation show that the probability that there are less than 19 complaints in a randomly selected week is 0.29 to 2 decimal places, and show you're working clearly. Okay, so here we have again to define our random variable. So we say that let x be the number of complaints per week, where a week obviously has 7 consecutive days. So x would have Poisson distribution with lambda equal to 7 times 3. So we have x distributed with Poisson distribution of lambda equal to 21. Since our lambda is 21 and is greater than 10, we use normal distribution. So X has normal distribution with mean 21 and variance 21 as well. And we want to calculate the probability of X less than 19. But since we are going from Poisson distribution, which is a discrete distribution, to a normal distribution, which is continuous distribution, we have to use continuity correction. So probability of X less than 19 using continuity correction is the same as probability of X less than or equal to 18.5. And we're going to standardize it using the Z values, and that's equivalent to probability of Z less than or equal to 18.5 minus 21 over square root of 21. And that becomes probability of Z less than or equal to minus 0.55. So that becomes probability of Z less than or equal to minus 0.55 is the same as 1 minus probability of Z less than or equal to positive 0.55. So we go to the normal distribution table and we find probability of Z less than or equal to 0.55, which is 0.7088. So we'll get 1 minus 0.7, that was 0.7088. And that gives us 0.29 to 2 decimal places. Part E. A period of 13 weeks is selected at random. Find the probability that in this period there are exactly 5 weeks that have less than 19 complaints, and show your working clearly. So from part D, the previous part, the probability that a week has less than 19 complaints is 0.29. So probability is 0.29. Now we define a random variable. We say let y be a random variable, the number of the weeks out of 13 weeks with less than 19 complaints. Less than 19 complaints. And since the weeks are independent of each other, we can use binomial distribution in this case. So y has binomial distribution with n equal to 13 and probability 0.29. Now it says find the probability that in this period there are exactly 5 weeks. So we want to find the probability of y being exactly 5. So we can use the formula, which is 13 choose 5, 0.29 to the power 5, and then 1 minus 0.29 to the power 8, and that gives us 0.170 to 3 significant figures.